So now I'm going to introduce Eric Boyd, founder and CEO of ResponsiveX. Eric and I go back at least 20 years. You're a Microsoft Azure MVP. I think you were one of the first ones in, right?
Yeah, in Azure, that's for sure.
Yeah, and co-author a step-by-step Azure SQL database from Microsoft Press, and is passionate about cloud computing and Microsoft Azure, and has been building applications for Azure since 2008.
We're gonna talk about Azure. We're gonna talk about Azure celebrating a birthday. It's 15 years old this year. Whoa. That's a little bit misleading. I'll talk about why. Some of you in the room may say, no, it's not 15 years old. And we'll talk about that as well. I'm Eric Boyd, as Phil mentioned. There's my contact info. There's me on a website. If you want to get in touch with me, that's the easiest way because all my social links are there. So feel free to reach out. Let me tell you a little bit about who I am beyond just the intro, beyond just that slide. I got started in technology in the mid-90s. I wasn't seeking out technology. I was young. I was a kid. I was in junior high. I thought I was going to be a lawyer. I grew up with a single mom. My brother and I, my mom did she tried really hard to do, everything she could for us. But we didn't have a lot. In fact, you might say we were poor. And I thought growing up, what I was told was I need to do one of two things to be successful. I either need to be a doctor or I need to be a lawyer. That's the only way I'm going to make any real money. Now, I don't mind blood and guts, but there is something about like a needle in an arm or like somebody's organs that just doesn't work for me. Like I can't handle that. So I knew doctor was out. Like that's not going to work out. So lawyer is it. I'm going to be a lawyer. So my whole childhood, I thought I'm going to be a lawyer. I'm going to law school. But in the mid-90s, I had a teacher that introduced me to computers. And I played with computers before. I played the Oregon Trail on the Apple IIe. But I'm talking about like using them for purpose. And so I started playing around with 3D modeling, and I really loved that. But what I really was drawn to was this web thing. I was, using the windows that looked like this and the browsers that looked like this. Yeah, if you've been around for a while, this will take us back. And I really loved this. I was building, websites for our school and our sports teams, and it was a lot of fun, right-click, view source. Oh yeah, just copy that, replicate it, all that good stuff. So much so that I, in the mid-90s, at 14, started a small web design company. And I was 14. That brings some challenges. I can't drive, but I was smart enough to realize that, and I partnered up with, I didn't take on a partner, I just worked with a lady who ran a marketing company, and it worked out really great. She took me to clients, I built cool stuff, got paid, and was having a great time. So about 15 or so, my wife, my now wife, who was my high school sweetheart then, she could drive. She was a few months older than I was. And so we were eating lunch. And I should also mention in this time, I also did some things that were probably not the best things to do because I was extremely curious and exploring all sorts of fun things and finding talents that I had. And I had a talent for creating synthetic driver's licenses, what you may call fake IDs. We're past statute of limitations, so I think I can talk about it. And, other things, black hat sort of things. And so as I'm eating lunch with my wife, my now wife, we're walking out to the car. I'm like 15 and a half, maybe close to 16. This guy comes running out of the restaurant. And he's shouting my name. Are you Eric Boyd? And I'm like, oh no. Like the thoughts running through my mind right now are not, he's looking for me in a positive way with just the energy that he had and the way he's shouting that. And so I paused for a second. I don't think I answered. I think it took me a little while to think about what my next play was here in like this big strategy game of life. And I eventually answered yes. And it turns out his daughter and I went to school. I didn't know that, but she must have told him I'm this kid that builds websites. And so somehow he knows that, he identifies me, and he's offering me a job. He literally right there on the sidewalk as I'm getting into my car offers me a job. I got this cool little web design thing going on. I'm making pretty great money, more money than I ever thought possible, especially at my young age. And I respond with 4 words. You can't afford me. I was 15. I had all sorts of fun things going on and maybe a little arrogant. Turns out we worked some things out. They could afford me. So I started doing some work. Now, before I advance, you might, when I tell you where I went to work, you might have some questions about it. You might be saying, where was your mom at? Because I went to work for this company called hookup.com. I'm 15 and a half. We built a .com in the late 90s. It's not what you think. We moved heavy-duty trucks. The parent company moved semis from manufacturing facilities to dealerships around North America. So Mack trucks, Volvo trucks that you see going down the interstate stacked up, hooked up together 4 at a time. So somebody thought it'd be a great idea to name the company Hookup. And then when we got into the .com world, just why don't we call it hookup.com? Like, what could go wrong? We're marketing to truck drivers anyway, so seems like a perfect thing. That's what we did. We got, VC funding. We did all the cool stuff. You can imagine at this time, we are early in this technology.com boom. This is a little premature. So like every other bust in the .com boom, we took a bunch of money, we spent a bunch of money, we did a bunch of cool things, and we went out of business. So I did get to build a cool feature though, the bidometer. This is what it looked like. This is our hookup.com. We built auctions to sell semis. So imagine people in trucking spending $100,000 on a truck on the internet with like essentially a credit card in the late 90s. It didn't really work out so well, but this is our website. I built that cool little feature. I built a lot of things here, but that cool feature mentioned in that article, the bidometer, at the time, it was really a really exciting thing. I'm not going to tell you about the problems we had with it. My team's over here laughing because I worked with some of them at the time, and we had some problems with the bidometer, but you can see it looks great here. So about that time, I'm working in the .com space, and the reason I tell you all this is just, I'm super curious, I'm exploring things. I'm learning a lot. Learning about building software, more than just web stuff, learning about distributed systems. We're running NT4 with the option pack to get IIS and MTS, if you guys have been around for a while. I've got web farms, I've got SQL Server clusters. We have to deal with outages and high availability and connectivity, so it's a fun time. But man, all of that stuff was a pain. I really just wanted to build cool stuff like the bidometer and not have to deal with the infrastructure. Now, when this collapsed, I left and started a software company for a number of years, and that was a lot of fun. And we were doing, cutting edge stuff in 2000, 2001. We built products on .NET before .NET was out of preview, using the Go Live licenses. The mid-2000s, early 2000s, Microsoft announces this awesome acquisition. What they're really doing is buying a person. You'll see this happen a lot in acquisitions. They might be buying a team too. Groove Networks was doing some cool stuff. If you're familiar with Groove Networks, Groove was created by the founder of Lotus Notes, Ray Ozzie, and it was like the collaborative editing experience of Google Docs and what we now use with Microsoft 365 back in the early 2000s. So pretty early for its time. So Ray Ozzie joins Microsoft. It's Microsoft's new brain. Also at the same time, Bill Gates is kind of stepping away. He's pulling back as chief software architect, and Ray Ozzie is filling those shoes. Around this same time, I transition jobs a little bit here, become a tech exec, thinking that's the ladder I want to climb for a while. And I go to LA in October of 2008. What was going on in LA in October of 2008? Professional Developers Conference. Super exciting. I'm there. There's Scott Guthrie. We've aged a little bit since 2008. I have too, not just Scott, but there we are at PDC 08, playing with surface tables, having a great time. What happened at PDC 08? Well, this happened at PDC 08. I saw Ray Ozzie unveil this on stage at PDC and was just like blown away. Like, this is super cool. This is going to solve lots of problems that I have. I don't have to manage any of that hardware in the data center anymore. We did stuff like this before. We called it application service providers or time sharing on a mainframe even. But this was at a whole different level. So I'm really, really excited. They show off, here's what we're going to do. Here are the services in the Azure Services Platform. I play with it. They deliver us Azure on 200 meg hard drives, portable hard drives, 200 megs, 200 gigs, 200 megs. They're small. They were small. It's 2008. And CDs. So what Azure was for us at PDC was we installed this stuff on our machines. We got these emulators, and then we went and requested access to like the real Azure in the cloud. And then maybe if we got lucky, we got access. And we did. It was great. Had a lot of fun. I started building things. So I was doing the tech exec thing, but I was super excited about Azure, curious, exploring. I had thoughts that this was going to be the future. And I'm in my evenings and weekends, I'm building stuff and trying to learn everything I can learn and absorb and understand about Azure. This is what it looked like in the beginning to create a new Azure service. So here we are, like, let's create our new Azure Hello World service. We have two options here. We can create a storage account or a hosted service. If you've been around for a while, hosted service got renamed to cloud services. It's the web and worker role thing that was there that's no longer there. I find it humorous that even though there were only two, they still want to provide a decision tree for us to help us choose the services, which is super needed today. But then we only had two to choose from. The portal kind of looked like this. At one point, we got this really sophisticated Silverlight portal at one point, if anybody remembers Silverlight. The iPad killed all that was Flash and Silverlight, and so HTML5 is the future now. Microsoft did the container thing before Docker was a thought. You can see in this visual, this was the early deployment of cloud services where we're taking a box and saying, here, hand that up to our staging environment. We'll do a slot swap on it or a package swap and put that in production. But this is how we built and developed apps in Azure. And then these would get deployed out to these data centers that were in these really cool containers. They shipped data centers on the back of a semi to a physical warehouse building, plugged it in, and in like hours, this thing would be fully online with power, cooling, bandwidth, all that sort of stuff. So this is really cool. We refer to these as IT packs. We've gone through several generations of Azure data centers now. It no longer looks like that, but we end up building out these data centers all over the world. Now at that time, it's about 2012, and I decide I can't do the corporate IT thing anymore. It's too slow, too much bureaucracy. It's not for me. And so I need to do something different. I need to go back to my startup roots and start another startup. Like, that's what I have fun doing, is building cool stuff, helping customers build cool stuff. So I started ResponsiveX. About February 2012, I'm thinking about, Azure. I believe Azure is the future. People look at me funny when I say that because AWS was over here and dominating at the time. And I have just this vision that no, Microsoft is going to crush AWS at some point. And so all my eggs in that basket, all we're going to do is specialize in building cool stuff on Azure, using all this Azure Cloud Services stuff. So it's February 2012. I'm lining up customers. I line up our first customer, Redbox. We'll talk more about that in just a second. At the end of February 2012, something happens. Azure is down for 8 hours. That is an eternity. If you depend on this, our internet's been down for 8 hours and then some. It's an eternity. We can't live without that. But this was early in 2012. Anything look unique about this article? Anything stick out to you? Anybody see the date on there? It's February 29th. Strange day. Wonder what happened. One of the cool things that Microsoft does whenever there is a problem is they release a root cause analysis. And so this gave me a lot of confidence that I was at least betting on the right horse, because they dive into every detail. Like, here is exactly what happened, and here is how we will ensure that it never happens again. I don't know exactly what the remediation was in this case, like all the way, but some developers somewhere that worked on the Azure platform decided it was a great idea to build date-time parsing libraries and calculation sorts of things. And so the process in the background renewed certs like every day or on some frequency. And it would just take the last day of the month, increment the year, go get a new cert. Turns out that doesn't work on February 29th of 2013. There isn't a February 29th. So this brought Azure down, and it just trickles throughout the system. So Microsoft has had some challenges here with availability and outages and building some things that are just resilient. Everything might be beautiful and well architected until that just one thing hits and gets you. So we think, okay, right? Microsoft says, we know what the problem is, we're never going to do this again. And then here comes February 2013. We have another outage. I feel like outages are always like SSL or DNS. And here we are, another certificate expires, and we have an outage. All right, they're learning from it. It won't ever happen again. The headline on this one, though, is great. A year later, so I'm out there trying to build a business, and no one cares about Azure. It's a tough sell, and with these kinds of headlines, it's not any better. But we've built Redbox on Azure at this point. It's great. But these outages are still causing us problems. So it's kind of like this. No one cares about all the things that worked well. It's that one little thing that we didn't account for, that when it goes wrong, like, everyone cares. We notice. So we want to try to identify those as we're building out these solutions for sure. So lots of cloud projects have challenges. I've seen lots of struggling cloud projects. Lots of cloud projects fail. I would say that it is not just cloud projects. We could just get rid of the word cloud there and say lots of projects fail. We're now applying this to AI. MIT says 95% of all of these AI proof of concepts are failures. Lots of AI projects are failing. Well, why is that? Well, maybe it's because we're not following some well-structured framework. We're not thinking about this in a very strategic, organized way. Wouldn't it be nice if there was such a framework? Turns out Microsoft has built that for us to help you, to help us deliver projects that are not going to be failures, that are not going to be struggling cloud projects. It's called the Cloud Adoption Framework. You may have heard about CAF. We refer to it as CAF all the time. If you haven't, if you are using Azure, if you are thinking about using Azure, you want to check this out. I'm going to walk through some things in the Cloud Adoption Framework because I think it is really essential as you're thinking forward about using the cloud, using Azure. Even if you're already using Azure, you may not be doing all the right things, and you could run into some challenges. So what is the Cloud Adoption Framework? Well, the first thing is a set of kind of 4 pillars that you should think about as you're adopting the cloud. You want to think about defining your strategy. I see this a lot with new hype cycle technologies and innovations. I see folks just gravitate towards whatever is cool and buzzword. Right now we're seeing it with AI. I can go build something quickly and awesome with AI, but I may not have any sort of real business reason or real positive outcome that's going to come from that. It's just cool and shiny and something I can build. So start with a strategy. I told you we'd come back to Redbox. Redbox was a perfect first customer for us. They had an amazing motivation. They had an amazing reason that they wanted to use the cloud. Redbox is in the Chicago, or was in the Chicago area. It was actually started out of McDonald's. I'm not going to tell you the backstory, but it was a project that actually got created from McDonald's, which is also in Chicago. They had a huge data center in the Chicago area that served all of their US operations, 40,000 kiosks across the US. They wanted to do a geo expansion to a new market. They wanted to expand. You'll notice these red boxes are a little bit unique, different than maybe the ones that you've seen before. They have a maple leaf on them because they wanted to expand into Canada. It requires some re-platforming. It turns out the payment technology in Canada is different. It's not just swipe, it's the chip and pin sort of thing, the EMV sort of thing. So we had to do a little bit of re-platforming, but what we came in and helped with is taking all of that technology that they had in the US and re-platforming it for all of that early Azure cloud services sort of stuff. We had some more services at this point. We were using SQL Azure, we were using Service Bus, we were using all sorts of things, access control service, but we had to re-platform all of that and run it in Azure using these kind of special things. But they had a great reason. They don't want to invest in another data center. What if this doesn't work? They've tried to expand into other geo markets before, and it failed. And so instead of having all that capital investment in hardware and equipment, they can just stop paying the operational expense and not have to worry about having a data center. So it's a great example of having a great strategy, a great business motivation. Like, here's my why and why I want to do that. They're a fantastic example of that. Then you need a plan. Okay, makes sense. Like, what are we going to do? How are we going to do it? Another great example of a customer of ours. Actually, before I do that, let me go back and say a couple of things in that plan box are really important to call out. It's not just developing a plan, but it's also that skills readiness piece is super important. That organizational alignment is super important. It's not just, again, a cloud thing. We see this all the time where a customer has .NET developers, SQL, and then they see this cool shiny thing over here in a container that they want to deploy, and it depends on Postgres and Kafka and all these things that they're not familiar with. That's not super well aligned with the organization unless they beef up and get familiar with it. So we take a trip down to Louisville, Kentucky, and we build out some cool stuff for Yum Brands, KFC, for doing delivery, mobile order pay delivery for KFC. A lot of fun. The stuff we generally get to work on are distributed solutions that cannot go down. They have to be up all the time because there's lost revenue that they'll never recoup. So we get to build this out. We work with their team. Their team's not super technical at this time. They have just primarily worked on kind of legacy point of sale systems. They don't know anything about building cloud solutions, building distributed systems, building APIs, web APIs. They don't know anything about microservices, NoSQL, messaging. That's not what they do. So we have to help them do that. We build out a beautiful plan. We've got perfect plan. We consider the skills of their team. They do have .NET developers. They're familiar with the Microsoft stack, so we want to use things that are somewhat familiar. We don't want to do this. Oftentimes we see customers build applications that look like just this one big ball of messy things. I'm not talking about just monoliths. I'm talking about just poorly structured monoliths. And so we don't want to do that, so we want to make sure we have things, loose coupling and all of that, because that gives us flexibility to do things. So we help them really think about how they design software too, not just the cloud piece of it. So for example, we know that our code needs to talk to a database. We're going to use Cosmos DB, but we might want to change that in the future. So we need some loose coupling there. We need some interfaces between that. We also have decided, because of some constraints we have, we need to run this like a state machine because of the way signals come in from the delivery partners, the Grubhubs, the DoorDashes of the world. It needs to run on a state machine with a timer. So after a certain period of time, I'm not going to go into all the business rules, but after a certain period of time, we've got to cancel these orders if we don't do something, otherwise we get penalized. So we have to use something like durable functions. We bring up the durable functions docs. It clearly says in the first line of the documentation, in the overview page, this is a great solution for running actors. That's exactly what we want to do. We want to run these stateful actors that are dealing with messages coming in all over the place. We build this out with these loose couplings in the middle. All is looking well. We're testing. It's going great. Like, the tests look good. Turns out the QA team sees some anomalies, but they write it off as being, I think it's just the way we're testing and the timings of things. Because remember, this is rapid events firing all over the place. So it's probably just the way we're testing. And so they just kind of brush it under the rug. They don't bring it up. We start deploying into stores where the events are firing in at rapid pace. We discover that that first line in the documentation for durable functions was meant for some actor model that never received a message at the same time, like 2 messages at the same time. It couldn't deal with this idea of multiple threads and concurrent things happening, and so it would choose a winner and everything else was a loser. And we would just drop them on the floor and it would ignore them. Well, that really doesn't work for us. We are losing messages all over the place. I end up with like the product teams on the phone, like hashing this out, and they're like, oh yeah, that shouldn't have made it into the documentation. That's not really what we meant. It's like, well, that's not super useful for me at the time. We didn't go down a certain path. I mentioned in that planning phase, we want to align this to the organization, make sure the skills align. We didn't choose Azure Service Fabric because there was great deal of complexity using Azure Service Fabric. Anybody use Service Fabric? Okay, a couple of folks. It brought lots of complexity. Durable functions simplified that in a much simpler model, and so that's the reason we chose durable functions, and it seemed like it was going to fit. But because of the way we architected this, we were also able to swap this out. In fact, I mentioned April earlier. April and I worked all night one night because they had gone live. We worked all night, and by the next morning, we had this swapped out from durable functions to Service Fabric, including everything deployed into Azure, all that good stuff, because of the way we had architected it. And you might also say, well, these dependencies on the back end, we could swap this out with something like storage if we wanted to instead of Cosmos if we really didn't need that. So I urge you to architect these solutions in a way that you have this loose coupling, because these kinds of things happen, and you want to be able to swap these components out when you need to. Oftentimes in the past, before the cloud, we would talk about things like, well, what if I wanted to use Oracle instead of SQL Server? And then somebody would say, we're never going to do that. Like, that's a huge investment to do that. And so we didn't architect it this way. In the cloud, we can swap these services out so easily and so fast. The other thing in that list was, just that skills readiness. And so education, make sure education is core. You guys are all here, that's great. Make sure you're educating the rest of your team, pointing them to resources, bringing them all up. We all win together as a team in our organizations. We all have to think like that. I didn't always think like that, but today I recognize that it is a team that's required to perform well. And so make sure everyone on your team is getting skilled up well. Then we go to this ready phase. We need a place to deploy this stuff. We need an operating model. We need a well-designed Azure environment. We run into customers all the time, and the quick starts that Microsoft provides you doesn't help in some cases. They spit out names that don't make sense or adhere to good naming conventions. But we run into existing Azure subscriptions that's like the Wild West. Stuff is just scattered everywhere, named all sorts of weird ways, and we can't make sense of it. So as you're planning your adoption of Azure or your usage, even existing stuff you have, like how can you adopt well-defined naming conventions, use tags to be able to really dive in and filter what you have. There's a great organizational hierarchy that you can utilize. We have resources in Azure. Above that, we have groups of resources. We have subscriptions. We have management groups. So use these tools to organize your resources in Azure. So you can make sense of it. You can find things. You can manage them. You can govern them. You can report on billing, things like that. The other thing that I would encourage is landing zones. This wasn't always a thing in Azure. In fact, early on in Azure, we avoided splitting things out into multiple subscriptions because there was so much complexity of, how do we get over into that subscription if we put something we need over there. We didn't have the idea of peering networks. We used VPN connections to get between networks and things like that. But today, landing zones are a great way to segment things, to segment them by subscription. So I would encourage you to check this out. This is in the Cloud Adoption Framework, CAF. You'll find all sorts of information about it, but it's basically saying let's build up a platform. We can put our applications in various subscriptions for each application so that we can manage and govern them accordingly. We can put platform things into their own subscriptions so we can reuse them, things like identity, things like networking and connectivity. So take advantage of that and use that as well. Last in these 4 pillars is the adopt. We talked about some of the things that we've done from planning all the way to adoption and building out these solutions. But if you are not doing this already, you need to. I cannot stress enough, you need to develop good DevOps practices. You need to develop good CI/CD practices. Oftentimes we use phrases like, the organization that does this will beat the organizations that don't in the marketplace. As we are venturing into the world of AI, where things are moving so fast, you can't safely use these AI tools, these AI coding agents and assistants, without having good DevOps practices. You may challenge me on that and say, well, of course I can. You're going to spit out code at a rate that's so much faster than you are doing it with humans. You need to be able to run those through build processes. You need to be able to run that through testing. And you need to be able to do it fast, automated, in parallel. You need good DevOps practices. I don't care what tools you use, there's so many options. You could go down the Microsoft stack and use all of the Azure DevOps sorts of things. You could go down the GitHub stack and use the GitHub things. You still have to use Azure boards because the project stuff in GitHub, no good. Don't tell Brian I said that though. You can mix and match them too. That's the good news. But you need to do this. This is essential for being successful, I think, for being successful in the cloud and being successful as we move forward in our innovation cycles. In addition to just CI/CD for your applications, you need to express your infrastructure as code. I think you should express everything as code. Why? I want to get rid of ClickOps. I want to get rid of people clicking around in the portal to make changes so that I have confidence that what we did in dev, what we did in test, and what we did in production are exactly the same. The exact same templates deployed them. The exact same code was used. I can see a history of that code. It's versioned. And so you need to start thinking about, if you're not already, automating your infrastructure deployments. And this capability has been around for a long time. What we're looking at right now is Bicep. It renders down to Azure Resource Manager JSON templates. It's a nice friendly language over the top of ARM. You could use Terraform, Pulumi, other things, but you definitely need to go down this path. One more story about the adoption phase that you should think about as you're building out these solutions as well. I mentioned earlier, we build solutions at mass scale, usually global solutions for customers. That's often what we do. Our customer base is across lots of industries, lots of sizes, but generally it's high performance, high throughput, massively scalable sort of stuff. So let's imagine we're building an API, which we did, for ingesting orders. Orders like chicken or coffee or something like that. We have users all over the world that we have to deal with. So we have this high throughput API. We're going to have this thing talk to something like Cosmos DB, some data platform, and we need to have this spread out across multiple regions. In this case, we'll just use 2, East US and West US in the US. And so we will have something in the front, like Traffic Manager, Azure Front Door, Cloudflare? Maybe not. We'll put something up there in the front, and we will direct traffic to our regions. We need to make sure whatever we depend on is also in those regions. Otherwise, we have dependencies going across the internet that's super slow and we didn't accomplish anything. In fact, we probably made it worse. Imagine putting a web app in one region and putting a database in another. If you try that with WordPress, WordPress is so super chatty, you can't use the admin portal. It just doesn't work. So we think about it like that. Sometimes you have to trust but verify. You know what I'm talking about? Somebody tells you this is the way it works, it'll be just fine. And you just kind of take that at face value and then you get into a problem. Well, we did that. This huge customer said, we have this beautiful Splunk logging platform. And don't worry, it's highly available and robust. We want to ship all of our telemetry and our logs to this platform. Here's the endpoints, go. No problem. Turns out, this Splunk logging platform is in an AWS data center on the East Coast of the US. And they say, it's not a problem. You're going to buffer it on the clients. And so it doesn't have to be synchronous. It'll be just fine. It just happens async, out of process. It'll be just fine. So we draw this arrow and we run. And for the most part, it is fine until you actually need logs. Because when something goes wrong and you are spitting out lots of telemetry, you're also overflowing buffers. And when you're doing that, you're crashing compute nodes and you're bringing down the entire system. So things like that you have to be super aware of, not making these kinds of hops, and making sure if you do, you understand the risk and you understand where you're going to run into problems. All right, so those are our 4 pillars. You can go, there's tons of content in the Cloud Adoption Framework. Go check that out. There are actually 3 more things that are just ongoing things that you need to think about. Security. How are we going to secure and manage that risk in the environment? Now, in the early days of Azure, this is how we logged into Azure subscriptions. Some of you don't even know this thing existed. But back a long, long time ago, Microsoft thought they would build a single sign-on platform in like the early 2000s, and they called it Microsoft Passport. It was a fantastic name. In fact, we should just rename Intra to Passport. Entree? We could do this all day. Intra, Entra, I've heard every pronunciation of this one. It is Intra, just so y'all know. Intra ID. We changed from Passport at some point, we then called it Live ID. We then got Microsoft accounts, the one ring to rule them all. We can do all things with a Microsoft account, except for things in our corporate environment, then we need something else, like an organization account. But then we got Azure Active Directory. So in the early days of Azure, when we were doing stuff with Redbox, we logged into subscriptions. There was no idea of Intra ID or Azure Active Directory or any of that. We connected live IDs to our subscriptions, and we could only connect like 5 of them or 10 of them. And so there's more of us than 5 or 10 of us. And so then you're creating these generic live IDs, and you're sharing them across the organization. What could go wrong? Eventually, we got Azure Active Directory. Now we have Intra. We have named identity things a gazillion times. So we could just call it Passport. It'll be fine. We get great structures, though, with Intra. One of the things we get is the ability to have all this role-based access control, a great hierarchy of security. So I just say this to say, make sure you are using these security controls well. Make sure you're using role-based access control well. You are not granting too many permissions. It's easy to say, hey, let's just make these guys owners. They can do whatever they want. Use this well, grant that least privileged access, minimize risk. The other thing I would encourage you to do is get rid of secrets where you can. If you are building applications and running them in Azure, you do not need usernames and passwords in connection strings. For almost all Azure services, you can use a feature of Intra and Azure called Managed Identity. You have service principals or application registrations in Azure. You can think of it like a service account. You tell your Azure App Service to run as that service account, test demo, and then it connects to SQL and Cosmos and all the things as that identity, and you no longer have to store secrets in config files. You're reducing your risk and your security footprint of having all those things floating around. So do that. Then you can do cool things now in Intra like conditional access. And so we want to say, hey, you know what? If I am in the US and I am in China within 2 hours and I'm logging in, something is probably wrong. We should stop that login. We should force an MFA. We should do something. And so make sure you're taking advantage of these features that we've gotten over the years in Azure through the innovation like conditional access. And there's so many more. I'm just scratching the surface. Passwordless with FIDO2. You can integrate FIDO2 and passwordless capabilities into your applications as well using Intra. So take advantage of those. In the early days, everything was on the internet from Azure. You would create a VM in Azure when VMs first came out. And by default, they would have a user account named administrator. And so you would just set the password. They had a public IP address. And sometimes, before you could log into the VM, somebody else has already brute forced that password, and they've logged into the VM, and they've taken control. So we started doing things like, okay, well, we can put that in a virtual network, we can put a VPN tunnel in front of it, we can wall that off. Don't put public IP addresses on things you don't have to in Azure. Take advantage of capabilities like VPN. You can do point to site, you can do site to site, you can do private connections like ExpressRoute. You can put it behind a jump box using the Azure Bastion service. So take advantage of all of those kinds of capabilities in Azure if you're not. Encrypt your data at rest. So we've talked about access controls, we've talked about network controls, but what about that data? We have disk encryption in Azure. We didn't always have that, but it uses BitLocker and encryption in Linux as well for that disk encryption. We can do it at the entire kind of data platform here as well on databases, so we can encrypt data at rest. We can also encrypt the data that's being moved, the data that's not just the connection, but that data, we can require the client with things like SQL Always Encrypted to have a certificate to be able to decrypt that data. So take advantage of those features for your sensitive data. When I got started in Azure, these are the Azure regions we had around the world. We had six data centers across 3 continents. This was like Azure's claim to fame. They didn't want to talk about data centers back then. The leadership at Microsoft wanted to stress you just hand us your container of code. Don't worry about what happens underneath. It's magic. We take care of that. So they wanted to ignore the fact that there was really data centers behind this. But this is what we had. Back in the early days, we had high availability constructs like availability sets. We still have them today. But we would say we want to ensure that our applications, our solutions are fault tolerant by spreading the applications out across multiple racks in a data center. And that's all well and good, unless there's a fire in the data center, which has happened in Azure data centers. There was a fire in a data center in China, causes the data center to go online. There was lightning that hit the south central US data center, took out a bunch of network equipment, caused the data center to go offline. Now we have 70 plus regions around the world, 400 data centers within those regions. I live 5 minutes away from the new, shiny AI data center that Microsoft is building. They keep buying more and more land. We'll talk about that. But it's really cool. They're expanding the platform massively. We're reaching people all over the world in regions that we've not been able to reach before. And they're split up into geographies. So we have data centers, regions, and geographies. A geography just represents data sovereignty or residency. And so you want to pick a geography like Germany if your data has to stay in Germany and never should leave Germany, or Italy or something like that. So you want to be mindful of that. It looks like this. This is a good way to think about it. Those data centers we call availability zones. That gives us single-digit millisecond failover between those. We can, instead of using availability sets that were just spread out across racks, we can say our web servers, we want them to be spread out across these data centers with single-digit millisecond latency. So if a data center catches fire, we still have a couple more there that we can fail back to. So we want to do that. We want to have a region, maybe another region for DR. So maybe it's okay for us to say, let's go from East US to West US. We can have a DR region as well. We'll have another 3 of those availability zones in there. And then they'll be surrounded by that geography to keep that data inside of a geographic region. So secure those. Think about business availability or business continuity. You got to manage those environments now. What are we talking about when we manage environments? Well, we really just have compute, our apps, some networking, data, but our solutions can get wildly complex really fast. We're building these microservices solutions that we have all sorts of APIs getting load balanced. We now have to make sense of all of that. And there are services in Azure like Azure Monitor that help us do that. This wasn't always the way either. We used to have every service did its own monitoring thing, and it was a challenge to try to understand what's really going on in your solution. So take advantage of Azure Monitor. It might be a little confusing for you to understand how all of this lays out because we use a lot of terms when we're talking about monitoring. You might be familiar with application insights, or you might be familiar with log analytics workspaces. Those are all things inside of Azure Monitor. So the log analytics workspace, that's where you're like storing your data, where you're interacting and querying your data. But then you have all these insights packages that run over the top of that to give you really kind of for-purpose insights capabilities, like insights into your applications or containers or networks or that kind of thing. There's a lot of capabilities here. that you should be aware of. And I just have some slides showing you all those cool capabilities. We can have all the best intentions in the world, but somebody's got to oversee this and make sure that we're doing the right thing. So govern and enforce this with policy. We have the ability to do that. We have the ability to use things like cost management and billing, set up alerts so that we know when we're exceeding budgets. Do that. Even do that if you're using a trial or a accredited account. Get familiar with those capabilities. You can do that in those accounts. So get familiar with them and use policy. You can create your own policy as well. All right, so now, all is well in my timeline. We've been doing cool stuff in Azure with customers. We have been building AI solutions with customers probably since 2014, doing a lot of cool machine learning stuff, helping them predict the future. We have t-shirts that say, I can predict the future with Azure machine learning. And then in 2022, this time of year in 2022, so 3 years ago, this is a game changer. It hits the users. Between November and January, this went from 0 users to 100 million users. The fastest growing consumer application in history, beating out every other social product. And people now think of AI, they think of ChatGPT, they think of large language models, and that's AI. And that's certainly part of it. When we think about AI, AI is really just some way we can make a machine do things that are intelligent, or make an agent or an AI perceive its environment, use some sort of learning, take actions to achieve a defined goal. One of the best examples I like to think about is Netflix. They did a contest back in like 2007 or 2008 called the Netflix Prize. All they were trying to do was increase recommendations for Netflix things that you might want to watch. Turns out when you go into your Netflix app, you see the recommendations. You will either click into one of those recommendations, you'll scroll across a couple of times, you'll scroll down and maybe across a couple of times. But if you don't find something to watch in a few scrolls, you go to Amazon Prime, you go to Disney Plus or something like that. So the recommendations they valued at $5 billion way back then. That was the value to their organization, was $5 billion. So they launched this contest to say, if you can improve our recommendations by 10%, we will give you $1 million. And this is coming out of like this world of AI and the cloud. And so all of this computing power that we have in the cloud, you can take advantage of and do this. So teams are competing, but they're not quite getting to 10%. So Netflix says, and also, just to keep you guys engaged, whatever the top team is every year until we hit that 10%, we'll give you $50,000. Keeps you engaged. So in a couple of years, a team finally hits it, but they only hit it because they took a group of them, pulled them together, ran as a team, and built this wildly complex ensemble model. Because of the power of the cloud and the fact that we can run a bunch of models, an ensemble model is just a really complex, lots of models running together. They hit the prize. Unfortunately, the model is so complex, Netflix can't actually use it and operationalize it. But it does what it set out to do. There were no real performance criteria with the contest. But that was enabled by the cloud. Another innovation that has been enabled by the cloud is transformer models. This is what lit up ChatGPT in 2022. In 2017, Google released this paper called Attention is All You Need. You can go download it and read it. It's a lot of fun. It's just a scientific paper, but explains what happens in a transformer model. That's what all of these models are based on now. GPT, BERT, all of those are based on this transformer architecture. And we had capabilities before like convolutional neural networks and recurrent neural networks. The challenge with those is they are sequential. And so it takes a long time for them to run, and it's just a slow process because you have to keep feeding in to that network. The transformer architecture allowed us to do a bunch of things in parallel. It's wildly expensive though, and heavy on compute power. It just happens to do it in parallel. So we take these simple concepts like neural networks, we make them super complex, like that. We need all of that cloud horsepower to make it work. I mentioned things like convolutional neural networks. We've been able to do advances in image recognition and computer vision because of these capabilities in the hardware we have and the NVIDIA GPUs we have in the cloud. But this is where the limitation came in with recurrent neural networks, that looping right there. Doing the recurrent thing is super slow. And so the attention is all you need paper really lit up OpenAI. That and like $13 billion from Microsoft. And a bunch of Azure GPUs. There's something that happened though, and is still happening, that we should be aware of as technologists. Because if there's something that we should be thinking about and applying resources to, it may not be what you do, but somebody's got to do it. Maybe the next generation, our kids or someone. This is the Little Giants pumpkin farm that's just minutes away from my house. My kids love this pumpkin farm. I don't know how successful it was as a farm. It's like 419 acres, but it's like a recreational sort of farm, an amusement farm. We go there and have all sorts of fun and what have you. These farmers are no longer farmers. Those 419 acres got bought for something like $190,000 an acre. They are never thinking about farming ever again because they made like $72 million one time selling the farm. Because these AI guys need lots of real estate. They're building cool stuff, but it takes a huge footprint. That is the land that Microsoft has acquired where I live. All of those red spaces, we're up to something like 1,900 acres or so at the moment. You can read about this online. It's really interesting what they're doing. They've even acquired a piece of land over here last week, another 135 acres at $286,000 an acre. My middle son is a dirt bike rider and he wants to buy some land to ride his dirt bikes. It's like we're not buying land anywhere close to where we live because it's selling for $285,000 an acre. So we need to do some things. We need to figure out how to deal with these land, the massive amount of space we need for these data centers. We need to figure out how to cool these things better. We need to figure out how to power them more efficiently because this also requires like the power of, this is just phase one. You can see in that lower left-hand corner, that's what's built out. They're just building out phase one right now, and that requires the power of the entire city of Milwaukee to power that thing. So our power plant is building them a new power plant just to power the data center. So we've got to solve some of these big problems as we continue to innovate and build on these technologies. So what is next? And then how should you prepare? I think there's three categories of what's next: compute, data, and AI. Confidential computing is super important. If you have sensitive data, we have security controls, we've talked about that, but if you want data you can ensure that it's never read by anyone else but the things that you want to allow access to it, this is where confidential computing comes into play. It's built into the silicon, trusted execution environments. It's available in Azure in various ways. We have these secure enclaves we can run our stuff in. Microsoft can't see anything that's in that silicon, and it's fantastic. It's in various products in Azure as well, and a new product that's in preview. So if you're building solutions and you need this kind of capability where you can collaborate in a secure environment, a clean room, there is a clean room capability that's in preview you should be aware of. You can sign up for that preview. If you want to know more, let me know. That's one area of compute that is super interesting and is going to be a game changer. This is also going to be a game changer. I keep thinking we're not that far away from it. Does anybody know what this is? It's a quantum chandelier. Microsoft has one of the coolest quantum implementations out there with these topological qubits that are different than everybody else's approach. This is a Majorana 1 chip that runs in one of those clusters, one of those chandeliers. This is a real thing. Microsoft is doing the quantum thing right now. It is not to a point that we can do super advanced things that we can't do with like an iPhone, but it's going to get there. And I think it's going to get there rather quickly. And this is important because there are a lot of things out there that if we aren't planning ahead, like if we're not using quantum-resistant encryption in our solutions, and we need to start thinking about that now before it's already in play, because if not, we can crack encryption with quantum computing. Quantum computers, what they're really great at are things like factoring problems. Like that's the thing. So things in physics, things in AI, these kinds of problems are going to be accelerated with quantum computing. You can get involved in quantum computing now in Azure. Microsoft has the Q# quantum language that you can play with, and you can go to quantum.microsoft.com and check that out. If you're not in the data space, if you're not already using Fabric, you should be. This is a fantastic, or Snowflake, or Databricks, or something like that. But you need to get your data in a state that is accessible, that is usable by AI. That is super important as we're going forward, as your organizations are wanting to adopt more and more AI solutions. AI depends on data. So you got to get that data somewhere that it's usable, clean, accessible. And then on the AI front, use GitHub Copilot, use coding assistants, use Claude Code, use whatever the tools are, but use those coding assistants and coding agents because they are going to make you superhuman in what you can do. You got to use them wisely. You got to prompt them well. Like, are they going to make mistakes? Of course, but it still will accelerate what you can do. Are you going to just let it loose and go build everything you need? No. You're going to need to assist it. On the side of the house of building your own AI, if you're building AI just consuming models, you're building solutions with AI, take a look at Microsoft Foundry. These are all part of Azure. They run in Azure on Azure's AI infrastructure, but it's a platform that has models that you can customize, tie in knowledge and tools, and orchestrate and build your own agents and your own assistants. It provides observability built on a responsible AI and trusted platform. So I use this quote a lot: luck is when preparation meets opportunity, from Seneca. I think you need to be prepared for these shifts that are coming. So a couple of ways to prepare: figure out what it is that you want to do. You guys have already figured out what you want to do, but maybe there's something else you want to do too. Maybe you want to change careers and think about being a data scientist or being an AI engineer or something like that. There's plenty of learning resources out there. And here's a link to career paths on Microsoft Learn, where you can go find this, and it will guide you down a bunch of training and resources and career paths where you can go learn a bunch of new things that maybe you don't already know. The Cloud Adoption Framework, definitely check that out. Make sure you are bringing in DevOps into your organization, because that is going to be essential as we accelerate in this world of AI. With that, thank you so much. There's my contact info. Thank you so much.